All right, so here's the second video in the unit 2 Pythagorean Theorem lessons. This is video 2 on the application. Now these applications are going to be quite simple. They're going to be based on the previous video that we did. I'll remind you that we had this visual image on the previous one. The short sides, if we made a square out of them, we would get short side A, or A times A, which is A squared. And we would have short side B times itself, because it's a square, so B times B is B squared. And then we talked about how we could take these two and add them together, and it would always give us our longest side, which we called the hypotenuse C, or just C times C, which is C squared. So A squared plus B squared always equals C squared. And that is for all right triangles, and you'll know it has a right triangle because it will have a little box in the corner, or it will say right triangle, or it will indicate in some way that one of the angles is 90 degrees. So we have this formula, A squared plus B squared is C squared, and that's about as formal as we ever had. And then we move to a piece like this, where in the previous video I had made an image and I gave an example of what if one's 25 and one's 36, what do? Well, we just add 25 and 36 and we get 61. Okay, well, what do we do with this? Why would we ever need this sort of information? Well, here's how we apply the Pythagorean theorem. I have my first example, and I tried to color code this as best I could. What you'll notice is that I have one hypotenuse. I'll always have one hypotenuse. It's always across from the 90-degree angle. And in this case, it's the red letter C. So here's what I observe. If I make a sketch off of this, and I'm not going to make a sketch every time, but if I made a sketch off of this, I would find myself saying I have that's a pretty bad sketch, but you get the idea. I have a 3 by 3 square, and 3 times 3 is 3 squared, or 9. So I have a 3 squared, or 9 size square here. All right, and on this side, 4 times 4 times 4 would be 4 squared, or 16. So 4 squared is all of this space. And then what I'd like to be able to do is I'd like to be able to understand that if I'm looking for the missing side, right? Notice how I had 3 and 4, but this one was letter C. We don't know that side. But I do know that this box is whatever the two small ones are added together. So 3 squared is, well, 3 times 3 is 9. And 4 squared, that means 4 times 4 is 16. And in the previous video, we added them together. So 9 and 16 make 25. So then I find myself wondering, if this square in total, as poorly as it may be drawn, it would go up and over. If this square is 25, what times itself equals 25, right? C times C is 25. And you might find yourself thinking, well, C times C is 25. So if I take the square root, I'd get C is 5. And that would be the answer, in fact. So we could use this technique to come up with the missing side length. Now, this is a very kind of a graphic way to do it. Graphic, not bad. Graphic, just visual way to do this. But I'd have to have a drawing. I'd have to make the boxes. I'd have to fill them in. I'd have to kind of go do a little bit of math. But I could use it, and I'd be using the Pythagorean theorem. But there's a non-drawing way to do it as well, and I'm going to squeeze it right into this space. I hope the video can be seen. In this case, I notice that I have two small sides, and I have my hypotenuse again. The hypotenuse happens to be red. It sure doesn't need to be, but it does have to be across from the 90-degree angle. So this is my longest side. So that means if I were drawing the picture, I would have the 12 by 12, or 12 squared. I would draw a square here, 5 by 5, or 5 squared. And the formula tells us that A squared plus B squared equals the C squared. Now we normally do C in red, but we don't need to. So I have A squared plus B squared equals C squared. So now I do kind of like I did here. 12 squared is 12 times 12 is 144. 5 times 5 is 25 equals C squared. 144 plus 25 is kind of like how we added them here. 144 and 25 is 169 is C squared. And then like I finalized this over here, I square rooted both sides to get rid of the square. And I get C is, and this is one we've memorized, 13. So this missing side, I guess we'll put units on here, inches. This missing side is 13 inches. And I'm able to calculate that using the Pythagorean theorem because we know the Pythagorean theorem works for every right triangle, and this is a right triangle. Now let's look at one more. So we've seen a visual way, we've seen the kind of the mathematical way, and now let's look at a problem that looks completely different. Now you'll notice that this is a little darker because I rewrote it in red and then copied it over in blue. But you'll notice in this one, I have something that's different. If I use my a squared plus b squared equals c squared formula, or that kind of template, well, I haven't, this is b, so I guess this must be a, because this is my hypotenuse. So 10 is my hypotenuse. If I know it's my hypotenuse, I'm just going to put 10 in the 10 spot. And I guess if b is, well, they're telling me it's b, then that's the thing I don't know. So this must be a. So 6 squared. So now I just fill in my template, and I find myself squaring numbers like I've done multiple other times. So 6 squared is 36, 10 squared is 100. This b squared thing, I still don't really know what that is, but I'm not scared of it because I can solve equations. I'm going to do minus 36 to both sides. B squared is, let's see, 0, make that a 9, make that a 10. This is a 64, and that's good for me because b is 8. And in this case, it's centimeters. So my missing side is 8 centimeters. Note the little bottom in the corner. These drawings will often never be to scale, so please don't try to use like your finger measurements or a piece of graph paper or grid paper or even a ruler to try to measure them. You could get lucky, but you'll most often just not get lucky. So try to use the box technique where you draw, or try to use the techniques I've shown here. Sometimes you'll have to find the hypotenuse. Sometimes you're going to be finding one of the missing sides. Math teachers call these missing sides legs, but that's not the most important thing. The most important thing is that you know the two small sides are the A and the B. The long one's C. You fill them in, you solve your problem, and you're done.